I would be remiss if I didn't show you a little bit of geometry associated with this. Textbooks tend to ask you to actually work problems by using this geometric approach I'm about to show you. I think that's very inefficient because, as we've seen in a previous problem, we got some rather ugly fraction answers. And to locate fractions on a grid, on a graph, would be quite difficult and problematic. And so I don't think graphing is a good way to solve these. However, I want to show you one because this, when we take this into our three-dimensional world in a future section, then we'll want to think about the geometry of that as well. Alright, so here's our problem. X plus 2y equals to 6. X minus 2y equals to 2. Let me solve it algebraically very quickly. And so this is like the very first problem I showed you. We could simply add equations and eliminate one of the variables. In this case, we eliminate y. Solve for x. X would be 4. And if we put 4 into here, 4 plus 2 should equal to 6. Y would have to equal to 1. So 4 plus 2 times 1, 4 plus 2 is 6. And 4 minus 2 times 1, 4 minus 2 is 2. So we know what the answer is supposed to be. X is 4, y equals to 1. Alright, I want you to see the geometry though. And I'm going to graph these equations of lines, because indeed that's what they are. They're equations of lines. So let's see, I'm going to use the 1, 2, 3, 4, 5, 6. I'm going to use the intercept method of graphing, and which works very well when you have x's and y's on the same side. So how does that work? For the first equation, if x was 0, y would have to be 3. 2 times 3 is 6. So we have 3 as a y-intercept. By the way, I'll put some scale numbers here. Conversely, if y was equal to 0, then x would be equal to 6. So that would be over here. And this first equation would be that line. So I'm going to label it as x plus 2y equals to 6. The second equation I'll do in red. If x is 0, then y would have to be what? It would be negative 1. Solved by dividing by negative 2. Y is negative 1. And if y is 0, x would have to be 2. So this would be these would be the y-intercept and x-intercepts. So I've graphed by using the x and y-intercepts. Alright, we'll connect the dots. And forms this line. And I'll write that equation. The red equation is x minus 2y equals to 2. And guess what? Look where they cross. Right about there, which is the point 4, 1. So you see it for yourself. That's the solution of a system of two linear equations is the intersection of lines, two lines. That is pretty amazing. I talked about this in an earlier chapter when we introduced graphing, about the history of graphing, how important that was to the scientific and technological development of our world. It literally helped bring us out of the Middle Ages in terms of science and technology. Being able to combine geometry with algebra into analytic geometry gave us a way of more powerfully analyzing our physical world. And again, shortly thereafter, calculus followed, and all that stuff kind of started falling into place. So I have to respect the algebra and geometry of this. However, in a practical sense, solving by graphing two lines is not very practical. So, but it will inform us about the next topic I'm going to introduce.